Given two strings s and t, return true if t is an anagram of s and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all of the original letters exactly once. Let's look at the first example. Our first input s has 3 a's, 1 n, 1 g, 1 r, and 1 m. Similarly, for t, there is the same amount of occurrences for each character. This means that s and t are anagrams of one another. Essentially, what you should derive from this definition is that one word is an anagram of another if it has the same frequency of characters. And the moment you hear frequency, you should think of a hash map. Hash maps provide us with key value pairs, which would be perfect for tracking the occurrence of each character within a given string. The moment you realize this, implementing it would actually be quite easy. We find the frequency of each character for the given strings, and then compare the frequencies to see if they match. Okay, coding this is the easiest part. The first thing we're going to check for is to see if s and t are the same length. Because if the length of s does not equal the length of t, they cannot be anagrams and we return false. Otherwise, let's populate a dictionary for both s and t. It's going to look like this. Now, before I iterate through these strings, this is how we're going to map out the frequency dictionary. So the key is going to equal the character, and the value is going to be the frequency of that character. Now, let's do the for loop. So for I in range of length s, let's populate it. The frequency of s at this specific character is going to equal 1 plus the frequency of s, and we're going to get that character and add 1 to it. So essentially all this does is we are getting that character in the dictionary and we are adding 1 to it. Otherwise, the default value will be 0, right? So let's do the same thing for t. Now, if these two strings are anagrams, their frequency dictionaries should be the exact same. So let's check for that. And this should be it. If we submit this, we should get, hopefully, a nice accepted. Nice. Okay, and the time complexity for this is going to be U of n because we are iterating through both of these strings. And the space complexity is also going to be U of n because we are creating these dictionaries and we're populating them. And that's going to be U of n as well. So, this is the most efficient way of solving this problem. Or is it? See, since we're only dealing with the 26 characters within the English language, we actually don't need to use the dictionary or a hash map at all. Instead, we can use the character's ASCII representation and store that within a fixed-sized array of size 26. This will make our space complexity from O of n to O1, which is constant. This is how it will look like. Okay, to solve this again, we are going to do the same thing initially. So we have to check if the length of s does not equal the length of t. We return false. Now here is what we're going to do differently. We are going to create a frequency array, and it's going to be filled with zeros, and it's going to be of size 26. Now we're going to iterate through the strings. So for I in range, length of s, essentially, we want to construct a list where a, the first letter of the alphabet, is at the first index, and z, the last letter of the alphabet, is at the last index. And we want all the letters in between to follow that order, right? So an easy way to achieve this is to take the ASCII value of the current character we're looking at and subtracting it by the ASCII value of a. So we're going to go to our frequency array. We are going to access the current character and we're going to subtract it by a. Now this alone will not work. We actually need to use the ordinal function in Python, which gets us the ASCII value of these characters. And once we see this character, we are going to up the frequency for that character by 1. And we're going to do the same thing for t. And it's going to look like this.
However, this time we are going to subtract the frequency by 1. See, if S and T really are anagrams, they should cancel each other out here, right? So we're going to do this. For n in frequency, if n does not equal 0, then we return false, right? Because these should cancel each other out. So if they are anagrams, we should just have a frequency list that is just filled with zeros, right? So if it doesn't equal 0, we return false. Now, if it goes through all of this and it doesn't return false, then it has to be true, right? They have to be anagrams. So let's submit this. Excellent. Now for this solution, the time complexity will be O of n, but the space complexity will be O of 1, because this frequency array is always going to be of size 26.